These days, as a result of increasing population, we are facing many issues of electricity. As we create renewable energy from non-renewable energy, like from solar energy and wind energy, this energy can be used in particular places only. Kinetic energy is the energy of motion and can therefore be found in every object that moves. So with piezoelectric tiles, we have found a new initiative in creating a new renewable source of energy. This power generating tiles project, we are making use of tiles to generate electricity, generating off-grid electricity just by walking around and powering straight light with your footstep. It consists of springs, gear, racks, pinion, and generators. The system makes use of a rack and pinion arrangement coupled with efficient gearing mechanism to drive mini generators that produce energy when pressed. We make use of harvested kinetic energy generated through vertical press foot movement. These tiles are designed to slightly displace vertically when someone walks on them. This vertical movement results in a rotatory motion that generates electrical energy.
How our electric generator tile works. We use piezoelectric material which have special properties. For example, take a look on the structure of silicon dioxide. It have a pattern called quartz crystal. When we see at specific angle, we can observe an hexagonal shape. When we apply a compressive force across the molecule, it will produce charge separation, which also means an electric field will created between the charges, lead to generation of small voltage across its quartz structure. If we apply a compressive force across the entire material, the charges in each structure will add up to generate a voltage across the material. Generally, piezoelectric concept is to convert a physical quantity into an electrical quantity. Due to high stability of nature, we use quartz and cut the quartz into a rectangular plate shape and place between the base and diaphragm. Electrodes also inserted between the quartz to measure the generated voltage. In this experiment, we applied first the force on the crystal through the diaphragm, and the force is distributed to the crystal. If any physical force, such as stress, applied to the crystal, it will deform and the charges form on the crystal surface. The structure of crystal gets compressed, and due to the deformation of crystal, the electrical are developed on the faces of crystal. The voltage generated is measured through the electrode. Thus, given formula E equal to Q over C, and this effect called piezoelectric effect. Lastly, due to special property of piezoelectric material, we can observe that the voltmeter reading increase as the external stress applied to it.
So firstly, we will make a hole on the bottle caps so that later we can glue the piezoelectric transducers on. So we glued the bottle caps on a plywood board by using a hot glue gun to be used as springs to return the setup to its former state each time it is being stepped on. We then glue the piezoelectric transducers to the water bottle caps. A piezoelectric transducer are used to convert mechanical energy into electrical energy using the piezoelectric effect. The wires are made sure visible for the circuit connection by gluing it to the bottle cap. The right connections were made by soldering the correct wire polarities and connecting them together. These two connecting wires will later be used to connect the model to a multimeter. We put bigger glue stick on top of the bottle caps to create a height difference between the piezo sensors and the pressure of the footsteps. Finally, we put a glass block on top of it as a surface for footstep tiles to put a pressure on. We then connect the connection with the multimeter to record the voltage reading when the tiles is pressed and released. When pressure are applied to the tiles, it causes a deformation in the material structure, which results in the separation of positive and negative charges within the material and generates electric charge. This electric charge can be collected and stored in a battery or used to power electronics device directly. When connected to a light source, here we can see that each pressure put on the tiles will light the source. Thus, we believe that this product can help in producing renewable energy.
The power generation by the footstep power generation can be stored in an energy storing device. The output of the generator was fed to a 12-volt lead-acid battery through an AC-DC converter bridge. The arrangement is shown in figure. The duration of lighting the bulb, for number of footsteps and corresponding energy stored are given in the table. The piezoelectric material converts the pressure applied into electric energy. When a force applied on piezo material, a charge is generated across it. Thus, it can be assumed to be an ideal capacitor. When three piezoelectric discs are connected in series, its equivalent capacitance becomes 1 over C equivalent equals to 1 over C1 plus 1 over C2 plus 1 over C3. Thus, voltage equivalent equals to V1 plus V2 plus V3. Hence, the net voltage generated in series connection in the sum of individual voltage generated across each piezoelectric disc. Output voltage from one piezo disc is 13 voltage, thus equivalent voltage is 39 volt. The relation between the weight of the person and power generated is plotted in the figure. From the graph, it can be seen that maximum voltage is generated when maximum weight of force is applied.
In conclusion, the electric tiles are very necessary to overcome the issues of electricity in our life. Not only that, but the electric tiles can also be used as a main source to generate renewable energy. This means that not only it can produce a great amount of energy, but it can also save the environment by reducing the excessive production of carbon dioxide. Hence, the electric tiles should be promoted to the entire world so it can be a norm to the society. The government and private sectors should take various initiatives so that the electric tiles can be implemented throughout the entire world. This way, the environment will be less polluted while generating more energy. We want to say thank you to the Centre of Foundation Studies for Agriculture Science, University Putra Malaysia, for giving us the opportunity and platform to participate in this competition.